Hi everyone and welcome back to Astro Digital Technologies YouTube channel where we break down analytics and database concepts to make them simple and actionable. I am Ezekiah Omoyemi and today we are diving into a fundamental concept in database design, which is database normalization rules. If you have ever worked with databases and struggled with redundancy, inconsistency, or scalability issues, normalization is the solution. It's all about organizing your data to ensure efficiency and reliability. In this video, we will explore the key stages of normalization: the first normal form, second normal form, third normal form, the Boyce-Codd normal form, and the fourth normal form. We will talk about what each rule means, why it matters, and how to apply it in real-world scenarios. By the end, you will have a clear understanding of how to create databases that are not just functional but also optimal. So let's get started on making your data smarter. We are going to be looking at the first normal form rule. A table is said to be in the first normal form when each table cell contain a single value and each column should have a unique name. So this employee table that you are looking at here has a unique column name. But looking at this table, it does not meet the first normal form rule. Why? Because you can see the skills column has more than a single value. To meet the first normal form rule, a table must meet the following conditions. One, each row must have a unique combination of values. No two rows can have the same values for all columns. Secondly, each column should contain only atomic values, meaning that each column cell can contain only a single value, not a list or array of values. In our case, you will notice that we have employees who can program and who can write SQL code. And we have employee James Smith who has only one single skill, which is database management. Now, the cells in this skills column that has two values in it has contaminated this table, preventing it from meeting the first normal form rule. To achieve the first normal form rule, we would split the skills column here into multiple columns. We are going to split it into skill 1, skill 2, each containing a single skill. To normalize this table, I have done that. Look at it here. Now, we now have this skills column has been split into skill 1 and skill 2, with each column containing just a single skill. So this table has achieved the first normal form rule because one, each row still represents a what? Unique employee. The skills column has been replaced with skill 1 and skill 2, with each column containing a single skill. The skills from the original skills column have been split and distributed across these two new columns. So we have achieved the first normal form for this table. Why is the first normal form important? It helps ensure data consistency, reduces data redundancy, and improves data integrity. Let us move to the second normal form. But before we do, don't forget to subscribe to our channel and hit the bell icon to stay updated with our latest SQL tutorials and data analytics insights. A table is said to be in the second normal form if it meets the following conditions. One, it must be in the first normal form. The table must already be in the first normal form, meaning it has no repeating groups or arrays. All non-key attributes are fully functional dependent on the entire primary key. Look at this basic employee skills table. It contains three columns. As looking at this table, it contains three columns: the employee ID, the skill ID, and the skill description column. The skill description column here is the non-key attribute, is the non-key attribute that must be fully functional dependent. So as it is, this skill description depends on the employee ID and the skill ID column as it is, which makes it not to meet the second normal form rule, as each non-key column must depend on the entire primary key, not just one part of it. You may be wondering, what does fully functional dependent mean? A column is said to be fully functional dependent on another column or set of column if its value can be determined by the value of other columns. In other words, if you know the value of the other columns, you can uniquely determine the value of the dependent column. For this table to achieve the second normal form, we will remove the skill description column from this table and create a separate skills table with skill ID as the primary key and the skill description. Then we are going to link it to the employee skills table via the skill ID. At the end, we will have two tables, which is the employee skills table and the skill description table. Let me quickly show you this. Now, I have split this into two. This to my right is the skill table, which contains two columns: the skill ID, which serve as the primary key, and the skill description column. Then we now have the employee skills table to my left with what? Employee ID and the skill ID. Afterwards, we are now connecting by referencing dis words, the employee skill table via the what? The skill ID column, which is a foreign key in the what? In the employee skill. You can see dis skill ID here is a foreign key in the employees skill table because we have a separate in the first normal rule, we have a separate table for employees which is the employees table with its own primary key which is the employee ID. Now that we are now having the skill ID to it, so the skill ID in the employee skill table here is the what? Is the foreign key. Connect the employees skill table skill to the skills table via the what? The skill ID. Dis new structure adheres to the principles of the second normal form as non-prime attribute which is the skill description here is fully functionally dependent on the entire primary key which is the skill ID, right? Let us move to the third normal form rule. I hope you are enjoying the tutorial so far. If you do, give this video a thumbs up. This will help us promote the video to more learners like you. What is the third normal form saying? A table is said to be in third normal form if no non-prime attribute should be transitively dependent on the primary key. In other words, the third normal form eliminates transitive dependency where a non-key column depends on another non-key column. Continuing from the previous example, suppose we have this table named employees with these columns, the employee ID which is the primary key here, the department ID and department name. In this table, the department name depends on the department ID, but the department ID is not the primary key in this table. To normalize this table, in order to achieve the third normal form, we would create a separate department table with department ID as the primary key and department name, removing the department name from this employees table. After splitting the table into two separate tables by adding the department ID to the employees table which serves as the foreign key in the employees table, we now have the department table separately with department name and department ID. The employees table is linked to the department table via the department ID column which is a foreign key in this employees table referencing the primary key in the department table. This structure adheres to the principle of the third normal form has no non-prime attribute, which is the department name, is transitively dependent on the primary key, which is the employee ID. In a future video, I will talk explicitly about transitive dependency. Watch out for that video by subscribing and turning on the notification bell so you can be the first to see it when it is released. Let us move to the Boyce-Codd normalization form. The table is said to be in Boyce-Codd normal form if one, the table is already in the third normal form, meaning it has no transitive dependencies. When there are no transitive dependency and a table has only one candidate key, a candidate key is a unique identifier for each row. The Boyce-Codd normal form requires that a table have only one candidate key. Look at this employees table with employee ID column, project ID column and project name columns. If project name depends only on project ID, not on employee ID, then we would need to create a separate project table with project ID as the primary key and name project name, linking it to the employees table via the project ID in order to what? To adhere to the Boyce-Codd normal form rule. And here you can see that we now have the project table and the employees table where the what? The employees table has what? Contains two columns, the employee ID and the project ID, and the project table contains two columns, the project ID and the project name. The employees table is linked to the project table via the project ID column, which is a foreign key in this employees table referencing the primary key in the project table. With this structure, this table adheres to the principles of the Boyce-Codd normal form as every determinant, the attribute that determines the value of another attribute is a what? Is a candidate key. So this is how what the Boyce-Codd normal form is saying. Now each table is in what? Is in Boyce-Codd normal form, and we have eliminated the transitive dependencies and multiple candidate keys, as in this case here, employee ID and the project ID. The BCNF is an important normalization technique because it helps ensure that each table has a unique and unambiguous primary key. Now, we can easily trace a project name to an employee based on the what? On the project ID. So One employee can be on two or more projects at the same time. So you can group the employee to a project based on the what? On the employee's ID, right? So non-key columns depend only on the primary key, as in the case of our project name that depends on the project ID. So these tables are free from transitive dependencies. By achieving the Boyce-Codd normal form, you have you can improve the integrity, scalability, and maintainability of your database. Do you have any specific questions about the Boyce-Codd normal form or database normalization? Drop them in the comment section. Let us go to the last normalization rule in this tutorial video. Lastly, we are going to be looking at the fourth normal form. The fourth normal form states that no table should have multiple independent multi-valued dependency, meaning a non-key column must not depend on another non-key column, and there should be no multi-level dependency. You may ask, what are multi-level dependencies in the first place? When we are talking about multi-level dependencies, dis occur when a non-key column depends on another non-key, which in turn depends on the primary key. Consider dis employee project table with employee ID, project ID, task ID and task description columns. If the task if the task description depends on both employee ID and project ID, as in dis case independently, for us to achieve the fourth normal rule, we would split dis table into separate employee tasks and project task table in order to avoid the multi-valued dependencies that is existing as it is in dis table. I have done dat, let me show you. Now, we now have the employee task table and the project task table. We have what? Created another column in the employees task table called the task ID, which is a foreign key in the employees task table here, but also it is standing here as a foreign key in the project task table. Now, the employees table contains two columns, while the project task table contains three columns: project ID, the task ID, and the task description. With this structure, we have achieved the principle of the fourth normal form, as there are no tables with multi-valued dependency. Each table contains only single valued attribute. So this is how you can standardize a table to achieve the fourth normal form. By applying these normalization rules to your database, you can ensure data integrity, minimize redundancy, and improve overall database efficiency. Let me know in the comments which of these normalization rule do you find most easy. Subscribe to this if you enjoy this video. Subscribe to this YouTube channel. Also share the video with your friends. See you in the next video.